This is a review for LO1 in statistics and probability. Okay, so let's start out with this first question where they gave us some raw data and asked us to find the mean, median, mode, range, standard deviation, and variance. Now, as you may remember, mean, median, and mode are measures of center, and range, standard deviation are measures of dispersion, how spread out the data is. Okay, let's start with the mean. The mean is the arithmetic average, and you calculate that by adding all of the given data points and dividing by the number of data points there are. So we would put in our calculator 7 plus 7 plus 9 plus 10 and so on all the way to the end. And we would divide by the fact that there were 12 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And once you plug all that in your calculator, we use this symbol for mean, and we would get a mean of 9.5. Okay, now we will calculate the median. The median you can remember as the middle number. And you cannot just pick the middle number of the raw data. You must first line it up from smallest to largest. So let's do that first. Okay, and it's lined up from smallest to largest, and now we must pick the middle position. So I remind myself there are 12 pieces of data. So if I were going to cut that data in half, it would be cut in half, right here, where we have 6 data points on the left of that middle line and 6 data points on the right of that middle line. In this case, there's not one score in the middle, so we take the middle of the middle, where we would do 9 plus 10 divided by 2, and we would get that the median in this case is also 9.5. That is a coincidence. It's not always the same as the mean. All right, let's talk lastly about what does the word mode mean. Mode is the most repeated score. Now, it is possible to have no mode if nothing's repeated, or more than one mode if there's a tie for the most repeated. In this case, the absolute most repeated score is 10, and so we would say the mode in this set of data is 10. Okay, now we'll talk about the 3 measures of dispersion, which are 3 different ways to measure how spread out the data is. So the first measurement is called the range, where you just take the maximum value of the raw data and subtract the minimum value of the raw data. So in this example, the maximum is 15, the minimum is 6, and so we would say the range is 15 minus 6, which is 9. Now, the range is not a very popular measure of dispersion, mostly because it's just using the 2 endpoints. It's not really telling us anything about the rest of the data that's in between those 2 endpoints. So to solve that problem, we do a calculation called the standard deviation. And the standard deviation basically finds the average, then for each data point takes the distance each data point is away from the mean, away from that average, and then it averages those distances. Now, it's a pretty complicated computation, and so we often use our calculator for this. If you're using the popular Casio calculator, the steps you do are you're going to press mode 3.1. You're going to have a table come up on your calculator. You'll enter your data. Then you'll press AC, which just saves the data. And then you press, after AC, you press Shift 144 to get the standard deviation value. If you have the white Casio calculator, you press menu 6.1 and then option 2. And so when we do that in our calculator, here's what we get for our standard deviation of this data. We would get a standard deviation. Now my calculator says 2.8123. When the data itself is just whole numbers, we will round our calculations to 1 more decimal place than the given data. So we'll say the standard deviation is 2.8. And there is one more measure of dispersion called the variance, and that is related to the standard deviation. It's just the standard deviation squared. And it's much better in your calculator just to press answer squared. You don't want to square something that you've already rounded because that would amplify the inaccuracy. So I'll take this output in my calculator, which says 2.8123, all of that, and just press the squared button. So it says answer squared. And again, we're going to round to 1 decimal place since our raw data had whole numbers. We can, our calculated values, we should take 1 additional decimal place to get the variance. Sometimes I say the standard deviation is like the little brother and the variance is like the big brother, because the standard deviation is always smaller and you square it to get the larger variance. Okay, so now we have some raw data, a lot of raw data, and it's asking us to create a frequency distribution using 7 classes. That means 7 rows. And there's a particular way I would like you to do this so that when I'm marking these, everybody is using the same categories or classes for their rows. Okay, so the first thing I'd like you to do is look at the raw data and find the minimum piece of raw data and the maximum piece of raw data. So I think it is 54 is the min and 110 is the max. Okay, so now once we know the min and the max, we can find the range, which is just the maximum value minus the min. So in this case, we get a range of 56. So now we have to figure out the class width. It has to be bigger than the range we just found divided by the number of classes they want us to create. That's the number of rows. So 56 divided by 7 is 8. That width needs to be bigger than 8. So in this case, we're going to make the width equal to 9. So now that we know the width, we can actually start to make our frequency distribution with 7 classes. So 1, 2, 3, 4, 5, 6, 7. And you're going to start the first class at the minimum value. So we're going to start it at, the minimum was 54. And then according to my instructions, add the width for every row following. So to go to the next row, we're going to add, remember we chose our width to be 9. And so this will become 63, add 9 again, 72, add 9 again, 81, add 9 again, 90, 99, 108. Now, it is a grouped frequency distribution, so we must also figure out where is the upper bound of each row, each class. And there's a couple ways you can do it. You could say, okay, up to 63, just but not including. I think when you have these whole numbers like this, it's fine to just say 62, 1 less than the 63 there. So instead, the next row, the third row starts at 72, so we'll end the second row at 71. The fourth row starts at 81, so we'll end the third row at 80, and so forth. And you can see here, we're just adding 9 each time. 89, and 98, and 107, and then 116. What is the point? The main point of these rows is that they have the same width, there are no gaps, and every raw data point will have a place in the row. Okay, so we've got our rows, and now we can start counting the frequencies. How many of each score can be found in each category? So I'll get started. I probably will just do a few and then fill in the rest. So between 54 and 62, that's 1, 2, and 3, 4, 5, 6. So there would be 6 in there. You may have noticed I missed 1, so let's change that. Actually, it's 7. So you can continue for each category And when you do that, you should get the following numbers. And by the way, here's how you can check to make sure that you counted the correct numbers. If you add up all the frequencies, it should be the same as the total number of pieces of raw data. So 7 plus 6 is 13. This is 21, 25, 26, 29, 30. So the summation of all the frequencies is 30, which should be the number of data points, and it is. So we've got it right. Now we can finally answer the question that they asked, which was the modal class. That means the most popular category, the most popular row, which another way to say that is find the row with the highest number as the frequency. It means the most people were in that, this is buildings, the most buildings were in this range. And so we would say the modal class is in this range. Okay, here is another type of graph you might find. It's called a time series graph. Just know time series means on the x-axis we have some time measurement, whether minutes, days, weeks, hours, years. And then on the y-axis, it is the other thing we are measuring. I grabbed this from the textbook, and it's talking about the number of murders in the United States and asking us, do we see a trend? Is the number of murders increasing, decreasing, or remaining the same? So there's a lot of things you could say about this. Here's some of the things I would say. First, I would say, well, if we're looking at this whole time period between 2014 and 2019, it's increasing overall. Now, I could also break it down a little more and say it increased from 2014 to 2016, decreased 2016 to 2018, and remained constant between 2018 and 2019. So that would be breaking it down a little bit more. You could also just talk about the max. The maximum was in 2016, and it was about 17,000 murders. Okay. So again, not much to study about this, but just be able to read a time series graph and understand it. Okay, so another type of plot you need to be able to make when you're given raw data is called a stem and leaf plot. And what a stem and leaf plot does is it says, okay, really it's just a fancy way of putting the data in order from smallest to largest, but it does it in a way that's very visual, and it shows different relative frequencies. So the stem will be the tens place, and the leaf is going to be the ones place. And you really want to look through all the data and find the smallest and the biggest. So I see 0, 2, and I think 57. So it looks like in terms of tens places, we're going to have 0, 10, 20, 30, 40, and 50. And so what you do is piece by piece, you go ahead, and 25 would look like this. 20 in the tens place, 5 in the ones place. 31 would look like that. 20 would go there. 32 is here. 13 is there. 14, 43, 02, 57, 23, 36, 32, 33, lots of 30s, 32, 44, 32 again, 52, 44, 51, and 45. Now, one thing I'll do just to make sure I have the correct number, I didn't miss anything. This is 1, 2, 3, 4, 5 by 1, 2, 3, 4. That's 20 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, great. So I have it there. We're not quite finished yet because we're going to then put the leaves in order from smallest to greatest. So I'm going to recreate the stem and leaf. And now for the leaves by row, I'm going to order them from smallest to biggest. So the first row stays the same as does the second row. The 20s place is going to go 0, then 3, then 5. The 30s are going to go 31, and then there's 1, 2, 3, 4, and then 3 and 6. And then the 40s are going to stay 3, 4, 4, 5. And the 50s is 51, 52, 57. So the benefit of the stem and leaf is you can see the most popular tens place is 30s. 30s is the most popular. It's the longest row with leaves. But we can also find the median and the mode just by looking at the leaves because it preserves the data. So again, if there's 20 pieces of data, then the median is going to cut them in half. We'll do the first 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'll cut it in half, and then we have the second half. So these two pieces of data are in the middle. Now be careful, that's not the number 2, that's the number 32. So when we're talking about the median, we look at the middle score, and since there's an even number of scores, there's 2 scores in the middle, 32 and 32, so we'll take the middle of the middle, and we end up getting that the median is 32. And also the mode. Mode is the most popular, the most repeated. So we'll actually just look down at the leaves and see which leaf is the most repeated. And again, 1, 2, 3, 4. That one is repeated 4 times, but don't say it's the number 2. It's actually the number 32. Okay. So you can tell all that from the stem and leaf. Okay, another way to represent raw data is by finding what's called the 5-number summary and making a box plot. So let's do that with this data. We've got data, it looks to me like there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. First thing you're going to do is arrange it smallest to largest, and then we will find the following 5 numbers. Okay, once it's ordered, the easiest is the min and the max. So the min is 228, the max is 804. Then it should be easy to find the median. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we were going to cut the data in half, this number would be the number in the middle, and we would have 4 that are less and 4 that are greater. So 623 is the median. Now Q1 and Q3, how do we calculate that? Basically, you take the data that is lower than the median, do not include the median, and find the middle of that. There's not one number in the middle, so to do it, we would have to do 489 plus 524, and then divide it by 2. Which ends up being 506.5. 506.5. I'll write it down here. 506.5. We do the same thing for the upper half of the data. We've got 4 pieces of data, so there's not one point in the middle. To find the middle, we would do 736 plus 777, divide all that by 2, and we would get 756.5, so that is called our Q3 number, 756.5. So that's our 5-number summary. And let me draw the box plot using the 5-number summary. So what I'll do is one by one, put dots on the number line where all 5 of those significant numbers are. So the minimum is 228, that's right about there. Then Q1 is 506, that's right about there. Q2 is 623, that's right about there. Q3 is 756, it's right about there. And the max is 804. So now how do we create the box plot? You are going to take the 3 inside dots. they're the most important. Draw a box and draw a line through the middle dot, and then connecting these endpoints to the min and the max, these are called the whiskers, you get your box plot. Now there's a couple more things we can calculate. One calculation is called the interquartile range, the IQR. And how do we calculate that? That's just Q1, because I want a positive number. It's Q3 minus Q1. So in this case, 756.5 minus 506.5, and we get that the interquartile range in this case is 250. Also, you can see it here. It's this distance. This distance is called the IQR, and it is 250. And we can use that interquartile range to decide on the boundaries to determine if there's any outliers, meaning any pieces of data in our data set that are extreme, much farther away from the rest of the data. So the way you calculate the boundaries for the outliers, there's a lower boundary, and that is at you take Q1 and subtract 1.5 times your interquartile range. So in this case, that's 506.5 minus 1.5 times 250. So when I calculate that, the lower bound is 131.5, meaning if I have any scores below 131.5, they would be called outliers. And let's go ahead and calculate the upper bound for the outliers. Similar, you take Q3 and you add 1.5 times the interquartile range. So in this case, that's 756.5 plus 1.5 times 250, and we would get 1131.5. So if there's any score above 1131.5, that would be considered an outlier. However, if you look at our scores, they're all within those lower and upper bounds. So I would say for this particular set of data, there are no outliers. One other thing you can see from the box plot is related to if the data itself is symmetric or not. And basically, to tell if it's symmetric, you look at this inner portion of the box plot, and if the median is basically in the middle, we would call this a symmetric distribution. And if there was one of the sides that was a much bigger space, a much bigger box, you would say it was skewed left or skewed right. Let me draw a picture on the next slide. Okay, symmetric distribution is going to be, let's say we had a histogram or some, and it basically, it's going to look like you could fold it in half and it would match on both sides. Or if you had a box plot, the box part looks like it's cut close to the middle. I don't care if the whiskers are different lengths. We're talking mostly about the box. Okay, skewed left. So skewed left would mean that there is an extreme value or a value that is pulling the data to look to the left. Something like that. If we're talking about a box plot, the actual box part would have the median more to the right, and you would have it look like it's bigger and being pulled that way. Again, I don't care about the size of the whiskers. It's more about the box. Okay, lastly, what does skewed right look like? That is when you have a bigger piece of data, like an extreme value or an outlier, especially pulling the data to the right, or if we're talking about a box plot, my box looks bad. It's where the data itself, the median is going to be on the left, and the bigger part of the box that's getting pulled to the right, regardless of the whiskers. Okay, so those are the different types of distributions. Okay, so let's do one last problem. This is where I'm not seeing all the data myself, but I do see the box plot, and from the box plot, I can learn a lot of information. So these are the 5 points that create the box plot. So I can tell right now the 5-number summary. I can see the minimum is 20, the Q1, so this first dot is 30. Looks to me like the median is about 44, doesn't look quite in the middle between 40 and 50. Q3 looks like 60, and the maximum looks to me about approximately 78. So what else can we tell? We could figure out the interquartile range, right? You just subtract, so the IQR is just Q3 minus Q1. And so in this case, it is 60 minus 30. So the IQR interquartile range is 30. By the way, these quartiles means we're cutting it into quarters. So you can think of it like 1 quarter, 2 quarter, 3 quarter, 4 quarters. So this interquartile range is 50% of the data in the interquartile range. Okay, we could also, if we want, we could calculate the upper and lower boundaries for to see if there's any outliers. So the lower boundary, if you remember, you just take Q1 and you subtract 1.5 times the interquartile range. So in this case, it would be 30 is Q1 minus 1.5 times the interquartile range is 30. And so we get the lower boundary is minus 15. The upper boundary for outliers, you would do Q3 plus 1.5 times the interquartile range. So 60 plus 1.5 times the interquartile range of 30, and we would get the upper boundary for outliers being 105. So as we can see here, none of my data is outside of those boundaries, so there are no outliers. And if you wanted to decide the symmetry, you figure out, is the median in the middle of that box, or is it being pulled to one direction or the other? This distance is about 14. This distance is about 16. That would be pretty symmetrical, in my opinion. There's not one side that is being pulled much greater than the other side. Okay, I hope this helps you as you study for your LO1 exam.